Hello friends, welcome to our channel Knowledge Amplifier. So in my previous video I already started discussion on handwritten alphabet recognition. Okay, that one particular handwritten alphabet is which one in English, right? That's what we was discussing with respect to our machine learning and image processing domain, and we have extracted several informations, several input features which are very important for our machine learning model training part, right? We have extracted median, we have extracted mean absolute deviation, we have extracted how many minimas and maxima, that is local minima and local maximas, are present when we plot our x coordinate and y coordinate with respect to time, right? And now in this video I am going to discuss some other very interesting features which we can extract, right? So for this particular discussion purpose I have taken one data set. I will be providing the link of my previous videos in the description box. If you want, you can go through that so that it will be easy for you to understand what is happening. Okay, so here I am reading the table, and let's run this particular piece of code. So this is my x, which you can see var1 is basically time instance which is started from 0. Okay, that is at time instance 0, what is the value? Then var2 is basically the x coordinate, var3 is basically y coordinate, and var4 is basically amount of pressure was given at that particular location. Okay, so this data is taken from tablet, okay, which we can easily take this kind of information, right? And let me show you the particular alphabet. So I'll be taking x coordinate and y coordinate. So see, this is nothing but M, right? English alphabet M, which is kind of tilted. Now what important feature we can extract, let us try to understand. So in this video the feature which we are going to extract is approximate velocity. Okay, so when you are writing something in tablet, okay, that time velocity, okay, or rhythm in writing that particular alphabet in different parts, the rhythm will be different, right? Like here you can see an important aspect of detecting letters written on a tablet is there is useful information in the rhythm or flow, okay, of how the letter is written. To describe the shape of the signal through time, it can be useful to know the velocity of the pen, or equivalently the slope of the graph of position through time. Okay, because you know velocity is nothing but slope of the our position versus time graph, right? So now we are having positions, there is x direction data points, y direction coordinates, and we have the time, so we can easily calculate the velocity, and the velocity will be different at different position, which we can be useful for identifying the particular handwritten alphabet. Okay, the raw data recorded from the tablet has only position, not velocity through time. So velocity must be calculated from raw data with discrete data points. This means estimate the velocity by using finite difference, which you have already studied in your applied numerical method course. Okay, final difference approximation, which is nothing but del x by del t. So delta x is nothing but what? Delta x is nothing but x2 minus of x1. Okay, and the velocity is nothing but delta x by delta t. Okay, so how we can calculate this? So at t2 instant, if the position is x2, and if t1 instant, at t1 instant if the position is x1, then the velocity is x2 minus x1 by t2 minus t1. That is nothing but slope of the x versus t curve, which you can understand here. Suppose at x1 t1, this is the point and this is the point at t2 x2, so the slope we can easily compute using this particular formula, right? So now let us try to compute that, and let's check what information we can extract. Okay, so here we can take differentiation d of x equal to, so basically here suppose I am having my x dot var2 is having the x coordinates, so these are these locations, right? So when we are computing this one, this formula x2 minus x1 by t2 minus t1, we have to calculate for all the data points. So how we can calculate? We will be basically computing the difference. Suppose this is x1, this is x2. So what is x2 minus x1? Then suppose this is x2, this is x1. What is x2 minus x1? Like that we will be calculating using diff function, right? So diff of, so here let me directly write d of x, d of t. For x direction the derivative, differentiation in x dot var 2, okay, that is x coordinate differentiation dot by differentiation of x dot var 1, okay, right? As simple as that. So basically x2 minus x1, like that for all the points we are computing the two successive x value difference, and this is for all the time we are computing two successive time value difference, and that is nothing but our velocity. Don't forget to give dot by, because these two are vectors, right? So now the thing is that if we just look into this dXdt, okay, so d of x, d of t, okay, so this is what we are getting. And point to be noted, let's check one very interesting thing: size of dXdt, okay, 35 cross 1. But if we check size of maybe x dot var 2, I'll be getting 36, 1, which is quite obvious that in the differentiation the length will be 1 unit smaller. As you can see here the length is 35, but here it is 36, because you are taking successive difference. So if there are 5, let me write here 5, 3, 2, 1. Now you are taking successive difference: 5 minus 3, 2, 3 minus 2, 1, 2 minus 1, 1. So when you are taking difference like this, always you will be getting 1 unit lesser length, right? That's what we are getting also. So keep this particular point in memory, that if you are computing like this kind of differentiation, obviously the length is going to be 1 unit lesser, right? So you can plot the velocity if you want. So I can give figure and here plot our x dot var 1 comma d of x, d of t. Okay, so this is time versus velocity plot we are doing, but time is having 36 cross 1 and velocity is having 35 cross 1 length. So if we simply plot, obviously we will be getting error because length mismatch, right? So what is expected? We will be basically removing the last time point, so 1 colon end minus 1. Okay, as simple as that. And now let's run this whole code. Let's check whether we are getting correct output or not. Yes, so this is nothing but what? Our velocity in y-axis and time in x-axis. Okay, this is the plot for x coordinates. We have done it for x coordinate, not for y coordinate. Now what information can be used as feature? Simple, max of dx. Okay, that is along x direction what is the maximum velocity. This can be used as input feature. Okay, like this for different handwritten characters we can compute this easily, right? So max of dx is nothing but going to be what? Max of this is nothing but going to be max of this value. Okay, that is 4.2970, right? So this is along x direction maximum velocity. Now suppose I am telling you in y direction what is the maximum velocity. So dYdT equal to differentiation in y value, so x dot var 3 dot by differentiation x dot var 1. Okay, right? And here max of y, max of dy we can say, that is for velocity maximum value, max of dYdT. Let's run this. So see, along y direction maximum value we are getting as infinite, and this is making one problem. Why infinite we might get? The reason is very simple. Okay, that is nothing but if in the denominator 0 comes, anything divided by 0 is infinite, right? 5 by 0, infinite. So we need to handle this kind of scenario. Now when we are using maximum function to get the maximum value in this particular sequence, obviously if infinite is present in this particular sequence, then it is going to return infinite, because infinite is the maximum value. There is no maximum value more than infinite, right? So what we can do, we can replace all the infinite values with nan, that is not a number, and for that we can write this particular piece of code, dYdT equal to standardizeMissing. Okay, and we are passing our original sequence, and here what we want to do, we want to replace all the infinite by nan, so we'll be passing inf, okay, as second parameter, and then compute maximum value. Let's check now. So see, maximum value along y direction 7.1617. okay, so I hope you have understood this. Now it might happen that you might get minus infinite at some point of time. Suppose minus 5 by 0, you will be getting minus infinite. So if we are getting minus infinite, then also we should replace by nan, right? So you can write like the code like this, so minus infinite and infinite. Okay, so whatever you will be passing as second parameter, the array you can pass, all those elements in this particular sequence will be replaced by nan, which is indicating not a number in MATLAB. So if we just now calculate max of dy, I'll be getting 7.1617, which is maximum value of the velocity along y direction. So today we have learned two more extra very interesting feature extraction, that is what is the maximum velocity along x direction, what is the maximum velocity along y direction, and this can be useful for classifying the particular handwritten character, right? I'll be continuing this discussion in my upcoming videos. Till then, stay tuned. Code and the dataset link will be provided in the description box. If you want, you can take from there and play with it. Thank you.